For checking the root bridge, we need to check the by default priority for all switches. All switches have by default priority. It means all switches have equal priority. So we need to move the second thing. The second thing is base MAC address of switch. We select the least base MAC address for becoming the root bridge. Now here we have 4 MAC addresses and the least MAC address is this because it have all zeros in first octave. So this bridge become root, or this switch you can say become root bridge. Now after becoming the root bridge, we need to select, or we need to check the root port of all other switches. Now I'm checking for this. This is switch 2, this is switch 3, and this is switch 4. I'm checking for switch 2. Switch 2 have 2 ports, this one and this one. Both ports have same priority, that is 128. It means we need to move the second thing. The second thing is base MAC address. So before checking the base MAC address, we need to check the link. This is the 19 coast link and this is also the 19 coast link. So now we move to the MAC addresses. Now the lowest bridge ID is this among this and this, because this switch number 2 have 2 ports. This port is connected with this MAC address and this port is connected with this MAC address. This is the least MAC address, so this port becomes root port. Now I'm moving on switch number 4. As I'm comparing, this link is the least one because these 2 ports have same priority, that is 128. Now I'm moving to the cost of the link. This link have least cost, so this port becomes root port. Now I'm moving to this switch. This switch have 2 ports. Both ports have same priority, that is 128. But the cost for both links are different. If the packet goes through this link, the cost becomes 19 plus this 19. And from here the cost becomes 19 plus 4. It means this path have least cost, so this port becomes root port. Now after checking the root port, we need to check every link have at least one, or at most one, or you can say exactly 1 DP. So for this link have 1 RP. This means this port becomes DP because every link must have 1 DP. This link also must have 1 DP and it have only 1 free and available port, so this port becomes DP. Now for this link, this port is RP, so it means this port automatically becomes DP. Now for this link, here the both links are free and available to assign. It means for this link, the one or any one port becomes DP and the other port automatically go into block state. So we need to check which port becomes DP and which port becomes block. So via this path, the cost to reach root is 19, and via this path the cost is become 19 plus 4. It means via this path this link have least cost, So this port becomes DP and this port becomes block. So the last scenario that I have is, this is our scenario. By the MAC comparison, we found this bridge or this switch is a root. So this is our DP, this is DP, this is RP. For this switch, this is RP. For this switch, this is RP. Now this is DP. This port becomes DP and this is block state. This is our final scenario that we calculated here. Now I'm using another scenario. These switches connected with each other like this. We need to check the MAC addresses. Here the MAC address, for example, I am using the MAC address as same. I am using the same MAC address, but I am using the connection are different, but the MAC addresses are same. So after comparing the MAC address, like I am comparing here, this bridge or this switch becomes root. So I'm using the same MAC address, for example, so this switch becomes root. But if I'm using the same MAC address and I'm using the different priority, for example, this switch have 32768 as a priority, this switch also have 32768 as a priority, this is also 32768 priority, but this bridge have 28672 as a priority. So the first thing to check is priority. The MAC address is different thing, or MAC address is the second thing to check. The first thing is to check priority. So the least priority, that is this, it means this bridge becomes, or this switch becomes root bridge. After selecting the root bridge, we need to select root port for every other switch. For this switch and for this switch, we need to select the root port. Now I am using the links. This is 1 Gbps links. This is also 1 Gbps. This is also 1 Gbps. And this is also 1 Gbps. And this is 10 Gbps links. It means the cost of this is least one. So for this switch, I need to select the root port. This port becomes root port because this port have least cost. For this, here by here the cost is 4, and by this way the cost is 4 plus 2. It means this port becomes root port. Now for this switch, it have two interfaces. Via this interface the cost is 4. Via this interface the cost is 4 plus 2. It means this port have least cost. It means this port becomes root port. This is root port for this switch. This is the root port for this switch, and this is the root port for this switch. Now I'm checking the all links, and we give the one DP for all links. For this link, this is the RP. It means this link becomes automatically DP. This link have one RP. It means this becomes automatically DP. Because every link must need one DP. This link have one RP. It means this becomes DP automatically. Now this link is covered. This link is covered. We have two more links. The first link is this. Now we are moving to this link. This link via this way, it have priority 2 because it is 10 Gbps link, and this is 1 Gbps links. It means it have priority 4. It means this is the least cost path. It means this port becomes DP. If this port becomes DP, it means this is in block state. Now I'm moving to this link. For this link, for this path, the priority or the cost is 4. The cost is 2 because this link is 10 Gbps. It means this is the cost of 2. Via this link, the cost is 4 because this is a 1 Gbps link. So this is the least path. So this port becomes DP and this port becomes block. So the final scenario for this is they are connected with each other like this. This is 1 Gbps link. This is also 1 Gbps link. This is also 1 Gbps link. This is also 1 Gbps link, and this is 10 Gbps link. It means its cost is 4. This cost is 4. This is also 4. This is also 4. But this cost is 2. It means this is least cost. The priority of all switches are 32768, 32768, 32768, and for this the priority is 28672. Now after checking the priority, this bridge becomes root. It means this port is root port because via this link it have least priority, that is 2. Via this link it have priority 4 plus 4. Via this link it have priority 4 plus 4. It means this is a least priority or least cost. This link have least cost. So this port becomes root port. As similar, for this router, this port becomes root port, and for this port, this switch, this port becomes root port. After checking the root port, all non-root bridges have root ports. Now I'm checking every link. For this link, this becomes DP because another port already becomes RP. This also becomes DP. This also becomes DP. For checking this link, this port become DP because via this link it have cost 2 and via this link it have cost 4. So this becomes DP, it means this port becomes block state. For this link via this port it have 2 as a cost, via this link it have 4 as a cost. It means this port becomes DP and this becomes block. This is the final scenario after STP conversion. Now we check the another commands for the scenario. This is the first scenario that we used. Now I have more commands in STP. The first command is show STP, or you can type, you need to type actually show spanning tree. You did not type STP, you need to type spanning tree. This is the whole scenario or whole detail about STP that we already discussed about. This detail is of root port or root bridge. This is this bridge or this particular switch detail, and these are the details of interface basis of this particular switch. Now the second command, go to your configuration mode. Now type spanning tree VLAN 1, because all ports are a part of VLAN 1, so I am typing here VLAN 1. Now you check here the priority and the root. You can statically set root for this port. If you type root here are two options. The first is primary and secondary. You can statically bound this port, or you can make this port as a root statically. If you type primary, it means this particular switch becomes root immediately. But if you type secondary, then this switch waits for time that the primary switch that already is root become down. If the primary switch becomes down, then the secondary switch becomes root bridge automatically. By this command, you create a static root bridge. The second thing for this command is priority. As you already know, all switches have by default priority, that is 32768. You can change the priority here, but the thing to notice is bridge priority in increment of 4096. You can use the priority, but the priority value is always the increment of 4096. This is the command for changing the priority of the particular switch. Now the next command is show spanning tree summary. Now here you can see the VLANs that we created on the particular switch, and for which VLAN how many ports are in blocking state and how many ports are in listening, learning or forwarding states. This is the all commands to change STP and to check the STP.